our first exposed service, we are going to use an image called jptetzo/http-env. We could use just like Nginx or Apache or some really simple web server like that, but I wanted to use an image that allows us to see the different backends. If I have let's say 5 Nginx servers and I connect to them, nothing will tell me which of the 5 servers I'm talking to. They will all tell me, oh, welcome to Nginx. So instead, we are going to use a little custom HTTP server that will tell us on which pod it's running. Okay. So here I'm going to split my screen in multiple panes so we can see what's happening, but you don't have to. So I'm going to, so it's split with this. Even like that. So kubectl get pods -w. kubectl get -w. W stands for watch. When I do that, it's going to show me like the, okay, let me just change my mind. I'm going to do it like this. When I do -w, that means show me the output of that command and then continue to watch for changes in these objects. So it's going, you see, it's still running. And if anything happens to any pod, I'm going to see that happen here. So here I'm going to do kubectl run http-env --image equal jptetzo/http-env. You do that, and then you see like that a couple of changes happening. There was like pending, then still pending, then container creating, and then running. These are the different stages of the life cycle for a pod. So pending here, that means, okay, the pod was just created. So at this point, we have recorded into etcd that we wanted that pod to exist, but we haven't decided yet where it should go, and it's not running yet. Then that's when the scheduler comes into play. So the scheduler notices that there is a pod that is not associated with a node. So there is a pod that needs to be placed, that needs to be scheduled. That's the job of the scheduler. So the scheduler is going to look at the workloads currently running on the cluster, the available capacity. It will say, okay, let's say that this should run on node 3. So it's going to stamp that pod saying, okay, you will run on node 3. Then that pod information gets pushed on the kubelet of node 3. So basically the API server tells to the kubelet on node 3, hey, you were asking me if I had work for you. That's indeed I do. I want you to start that specific pod. That's when we enter container creating. Container creating, that's another way to say pulling the image. So it stays in that state for a few seconds. And once the image is pulled, then we can enter running. So now I have this http-env pod up and running. So now I'm going to scale that. So I'm going to do kubectl scale. What do I want to scale? A deployment. Which one? http-env. How? With 10 replicas. And we see the same thing happening. We have like 9 more containers pending. They very quickly are scheduled and go to container creating. And then a few seconds later, they are running. So now I have 10 pods running http-env. If I do kubectl get pods -o wide, so to have like the wide output, then I see the IP addresses for these pods. So for instance, if I take one of these pods IP addresses at random and I run curl on it, it's going to tell me connection refused because this service is not listing on port 80, but on port 8888. If I try on port 8888, I get the environment variables, that's why it's called http-env, served at JSON. The reason why I want to do that is because in the environment, I have the host name, and the host name basically tells me which pod is serving my request. So remember this morning I was like bragging about my JQ skills. We can use that again now. I can do pipe JQ dot host name. So that means get just the field host name in that little JSON object. And that outputs just the name of the pod that served that request. Okay, but this IP address over there, that's just the IP address of one pod. So if I want to load balance traffic, that doesn't help me. And if that pod goes away, then that IP address becomes invalid. So what I want to do is place a load balancer in front of my pods so that number one, it load balances traffic. So I just send traffic there and I'm going to get replies from all the pods. And number two, the IP address of the load balancer will remain stable over time, even if the pods go away, come back, go up and down, etc., etc. And I achieve that with a service. So I do kubectl expose. What do I want to expose? A deployment. Which one? HTTPN. And if I do only that, it's going to tell me, hey, what should be the port number? So I have to add -- port equal 8888. Right. That's it. So it tells me service exposed. Now if I do kubectl get services, I see that in addition to the Kubernetes service that was already there before, now I have HTTPN. So a random cluster IP was allocated for it. Like on my cluster is that, but on your cluster it's going to be something different. And I can connect to that IP address with curl on port 8888. And I get a reply from one of my pods. So, okay. So here again, I'm going to use JQ to extract the host name. And the reason why I do that is because I want to show that when I do multiple requests, they get served by different backends. You know, like if I look just at these 5 characters here, I see that they change for each request because each request is served by a different backend.